One final technique that we will look at in this section is the idea of logarithmic differentiation. And if you notice this function y equals this nonsense over here, you don't want to be working with a quotient rule, let alone while doing this quotient rule, write the denominator times the derivative of the numerator. Well, now we're doing a product rule, and then minus the numerator times the derivative of the denominator, another product rule. That's a lot of rules to keep straight. One thing we can do to ease the pain is to take the natural log of both sides. And this allows us to do something like this here, where we can take the natural log of x plus 1 plus the natural log of x minus 2 minus the natural log of x minus 1 minus the natural log of x minus 2, where this feels a lot easier because we have some relatively easy derivatives to compute here with these logs all separately, whereas we would have had to use a quotient and product rule up here in the first place. There is a little trick at the end, which is kind of why you needed the implicit differentiation before this. One thing that we'll end up doing is from this point taking the derivative, and I'm going to represent the derivative of the left side like this, y under y prime, right? The derivative of y is y prime, or dy dx, like with the implicit differentiation. And over here we will have 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2. I just realized this is supposed to be a plus. And that's great, except, and we're trying to solve for y prime, we're trying to get y prime, it's right here, the derivative of y is y prime, but this y is messing everything up. So if we can isolate this y prime and figure out something to put in for this y, I think we're going to be set. So we can multiply both sides by y, and that will get y prime isolated. But now we still have this y to worry about. If you look back at the original function in black up here, you can see that y equals x plus 1, x minus 2, x minus 1, x plus 2. And so the trick is to get this entire right side and x's down here. You need to go back and substitute this original equality for the x's in for this y. So you'll get something like this. Y prime equals 1 over x plus 1, 1 over x minus 2, 1 over x minus 1, 1 over x plus 2, with the correct signs in here. And then lastly, go back and substitute in that x plus 1, x minus 2, x minus 1, x plus 2 in for that y. And there's no reason to multiply this out, no reason to distribute this to every term. You just leave it like this. This is your derivative. Let's look at another couple examples.